Back guys, today we're back with another problem, and today's problem is an interesting problem on product array puzzle. Okay, so this is categorized under an easy problem, but this is definitely not an easy problem if you don't know how to manage this particular problem in O and time complexity. Okay, so let us first describe this particular problem statement and then try to understand what it is saying. So I'm going to divide this problem statement into two parts. One is using the easy solution and how we can analyze this particular solution. So the first is we will be given a nums array and construct a product nums array such that the nums of I is equals to the product of all the elements except that particular element. So say for example we have an element. Say for example we have this 10, okay, 3, 5, 6, and 2. Okay, so this is the say for example this is our initial array. Okay, this is our initial array, and what the question says is we have to make another array for every values. Say for example 0, 1, 2, 3, and 4. I'm indexing it. For every values, what I have to do is I have to return the products of the number except the number and the other elements. So I'll be explaining this. So for example, when my I is at 0, okay, when my I is at 0, what I am basically doing is I am multiplying the rest of the numbers and returning an answer. Say for example, it's 3 into 5 into 6 into 2, okay, which is equals to 180. Okay, now my next pointer moves. Okay, so right now I was there. Okay, so now my next pointer move from here to here. Okay, similarly I'm moving from here to here, I'm moving from here to here, I'm moving from here to here, and so on. Okay, so but how I am going to do that? So there will be a pointer method by which I will be incrementing, but before that I am going to execute the run. So when my I equals to 1, right now I'm over here. Okay, so now what I have to multiply is the left element and the right elements. So the left element is 10 multiplied by 3 into 5 into 6 into 2. Okay, so I will get an answer of 600. Okay, now let's try for the rest of the values. So rest of the values will be say 10 into 3 into 6 into 2 is equals to, I will get a 360, and for I equals to 4, I equals to 3, I will get 10 into 3 into 5 into 2, I will get a 300. Okay, and for I equals to 4, what I'm going to get is 10 into 3 into 5 into 6, which is equals to 900. Okay, so my final array is going to look like this. My final array is going to look like this. It is going to contain a 180, it is going to contain a 600, then 360, 300, and 900. So I will write 360, 300, and 900. Okay, so what will be the easy approach to do this? What will be the easier approach to do this? So say for example I have the value sample array. I'm going to take a sample array 1, 2, 3, and 4. So now let's do this. So the easier trick is what I can do is I am multiplying all the numbers. So I can multiply 1 into 2 into 3 into 4, which I will get a 24. Right now my first element will be 24 by 1, which is equals to 24. Okay, now come to the second example. The second example I'm having a 2, right? So what I can do is the total multiplication is 24 by 2. I can get an answer as 12. Now I have a 3. So what I can do is 24 by 3. I can get an answer as 8. And then lastly, what I have is 24 by 4, which is having a 6. Now you will say, Arnav, is this answer correct? Let us re-verify it. So when I'm verifying it, what I can get is for the value of 1, I will have to multiply 2, 3, and 4, which is 4 into 3, 12 into 2, 24. Okay, now I'm at here, so I have to multiply 1 with 3 and 4, so which is 12, right? Now I'm at here. Okay, so I have to multiply 2 into 4, which is 8. Now I am at here, the last element. Now I have to multiply all the elements to my left, which is 3 into 2 into 1, which is 6. So and you will say this is a very easy approach and we can get the answer solved. But wait, this question has some constraints. So let us check those constraints. So you will get to know that whatever the numbers we are storing, we have to store the numbers at a 32-bit integer value. And 32-bit integer value can store a maximum of 2 into 2 to the power of 32, right? Which stores 2 to the power of 32 values. So in the case of 2 to the power 32 values, what I can see is, say for example, my array elements are like this. Okay, but what if my array elements are like this? Okay, now I've been taking a sample array and I'm trying to understand how I'm going to do that. So let us take an example: 10 to the power of 8, 10 to the power of 9, 10 to the power of 7. Okay, so in this case, will my problem work or not? I have to check. So if I see, what I'm getting is for particular this, I have to multiply 10 to the power of 9 into 7, which is definitely a value 10 to the power of 9 into 7, right? So which is 10 to the power of 9 plus 7. So if I'm doing that, I'm getting a value which is larger. So I'm getting a value which is larger. I can take another example. say 10 to the power of 4, 10 to the power of 3 and 10 to the power of 5. So if I'm considering this particular thing, what I'm getting is, say for example I'm taking this value, say for example I'm taking this value or I'm taking this value. So for the last value, what I will be multiplying is 10 to the power of 4 into 3 is greater than 10 to the power, is greater than 2 to the power of 32. So definitely my answer will give an overflow. Answer will give an overflow and it cannot be stored inside the integer value, right? So how I can efficiently solve this particular problem statement? By little bit thinking out of the box, right? So how I can think it out of the box? So what basically I will be doing is, I will be showing you how we can do this. So we will be having a left array, okay? We'll be having a right array, okay? We'll be having a product array. We'll be having a left array, we'll be having a right array, and we will be having a product array, okay? And we are going to solve this problem accordingly. We are going to solve this problem accordingly. So let us take the example of the array elements. So the examples which I'm going to take is 3, 4, 6, 1, and 2. Okay. So now I have 3, 4, 6, 1, and 2. So in the left side, say for example, in the left side, now my first task is I have to move right. I have to move right. So what I will basically doing is, I'll be first making a table out of it, because that is more important. Otherwise, it will be damn confusing which elements I'm taking, which multiplications I'm doing, and all those things. Okay. Now I have done a left and the right bifurcation. So first I am at 3, right? First I am at 3. So my initial goal is, whenever I will be at 3, what is the element which I am at left, which is the element which I am at the left. Okay. So say for example, right now I am at 4, right? Right now I am at 4. Say for example, right now I am at 4. So whenever I have 4, then my left will be 3 into 1, right? 3 into 1. So my left is just 3 because only there is one element, right? And what will be my right element? When I'm at 4, when I'm looking at 4, the elements to my right side is 6, 1, and 2. So I'll be putting 6 into 1 into 2 over here, okay? Now let us come over here. Now my element has shifted, okay? So now I am at the pointer 6. So what are my left elements? The left elements will be 3 into 4, 3 into 4, and the right elements will be 1 into 2, okay? Now I am at the 1. So right now what will be my left elements? My left elements will be 3 into 4 into 6, and the right elements will be 2, okay? 1 into 2. Sorry, it will be only 2. Just erase. Yeah. So my right element is 2. So now finally, what you can see, I have moved over here. What you can see, I have moved over here. So when I have moved at the last stage, what are the left elements which I have? The left elements which I have will be 3, 4, 6, and 1. 3, 4, 6, and 1. Okay. And the last element which is there, what I can see is nothing, because there is nothing to my right. There is apparently nothing to my right. Okay. So this is how I am going to solve this particular problem. Initially what I have explained is this. Okay. So now let us take out the values. So my left will be first is 3, then 12. Okay. Now we have 3 into 4 into 6. So we have a 3 into 4 into 6. So we have 12 into 6, right? Let us just check the calculation. Yeah. So we have 144. We have a 144. And what else do we have? We don't have a 144. We have a 72, right? We have a 72. Sorry. We have to remove this. Yeah. We have a 72. Okay. 3 into 4 into 6. And for 3 into 4 into 6, we'll be having 6 into 1 into 1. Okay. 1 into 2. Then 2. So for this, we don't have any values, right? So for the right value, let's come with the right. Let's come to the right. Let's come to the right. So elements we have is 12. Okay. We have a 12. Okay. We have a 2. That is also correct. Then we have another 2. We have another 2. So let us take the example where 3 into 4. We are doing 3 into 4. That means we are at 6. That means we are multiplying 1 and 2. Okay. 1 into 2. And when we are at 1, we are multiplying with the predecessors. Okay. That's fine. That's fine. Okay. So we have this. So now our task is to multiply the left with the right. Multiplying the left with the right. So when I'm multiplying the left with the right, what are my first values which I'm getting? So first I'm getting a 36. First I'm getting a 36. Okay. Next I'm getting 12 into 2, which is a 20, which is a 24, which is a 24. And now 72 into 2, which is a 144. Okay. Okay. And the 72 initially as 72. Okay. And what else do I have? What else do I have? So I also have a 24 into 2. I also have a 24 into 2. So which will become 48. Now your question is enough how you are understanding, how exactly is this working. So if you see my left values are, if you see my left values, right value here 48, you see, yeah. So the left values are 3, 12, 72, okay, and then there is another 72, yeah. So I have 2, 2, 12, and 2, okay, and then I'm getting the multiplying this, and this is my product array. So I'm going to verify my product array whether actually this works or not, So initially what I have is a 3, 4, 6, 1, and 2, 3, 4, 6, 1, and 2. So if I take the value of 3, if I multiply with 4 into 6 into 1 into 2, what I'm basically getting is 4 into 6, 1 and 2. I am getting a say 12 into 4, a 48, which is correct. The first element matches. Now I'm at the pointer here. So I'm multiplying 3 with 6 into 1 into 2. So 6 into 12 into 3, which is a 36. That is also matching. Now I'm at 24. So now how I'm getting 24, I'm at here. Okay, so I'm getting 4 into 3, which is 12 into 2. So I'm getting a 24, which is also matching. Now my pointer is at 1. So I am multiplying 3 into 4 into 6, which is a 72 multiplied by the 2 at the right. So it gives me 144. So I also got it. Now finally I'm at the last. So I have a 3 into 4 into 6 into 1, which is 12 into 6, which is 72. Okay, so which also matches. All these are matching. So this is how we are going to solve this particular problem using a left array, a right sub array, and also we have a product. So in the product we are going to store the multiplications of the left with the right. Okay, so now how we are going to code for this particular solution. Let's come to the coding and implementation part. So we have this function given over here. We have this little function given over here. What our primary task is, we have to make a left array, right? We have to make a left array. So int left equals to new. What I can take is since it is telling, yeah, I can take is int new. Int left equals to new. Int I can take nums dot length. Okay. Int right equals to new int nums dot length. Okay, now I've taken left and right. So initially my left position equals to 1. Okay, now I'm going to traverse it. I equals to 1, I less than nums dot length, I plus plus. Okay, my left of I is equals to left of I minus 1 multiplied by the number minus 1, so nums of. Okay, similarly I have to do the thing for the right one. So I can just paste it and I can write right over here, and my last element, which is nums dot length minus 1, as 1. Okay, what else do I have? So I have to traverse the loop in the reverse direction for the right order. So for that I equals to nums dot length minus 2. Okay, nums dot length minus 2, I greater than minus 1. Okay, and then minus 1. For the incrementation part, I can write it like this: right of I equals to right of I plus 1 into nums of I plus 1. Okay, the for loop is also done. Now in my answer array, which will store the product, okay, for I equals to 0 less than nums dot, okay, answer of I is equals to left of I into right of I. I'm going to return the answer. So let's compile the code. So it is saying, okay, let's compile. Int left equals to new int left equals to, so I have to put the array symbol. I missed a major mistake. So now it is saying that long cannot be converted into long. Okay, so I have to take a, maybe I have to take a answer, I have to convert it into long. I have to convert this into long, and I have to check the driver code once more. I just want to check the driver code whether they have taken. Yeah, we have taken a long, so I can't change. So I have to take the long over here. I have to take all the arrays as long. That's a tiring job. That's a tiring job. Long. Now let's try. Int cannot be converted to new long. So let's compile. So yeah, our code is working. We should submit the code. So you can see the amount of test cases they have given in this easy problems. It's not the usual problem of GFG. It has 1 lakh test cases. Okay, so that 1 lakh test cases arise. That's the reason I have solved using this method. If I have solved using the method of just taking the number, multiplying all the numbers and dividing by the number itself, it would surely give me an error, because then it won't be able to handle larger values. That's the reason we are this is an efficient and optimized approach. Okay, so we can write it over here to store left values. Okay, and for this we can write it over here to store right values. Okay, to multiply left with right and store it in answer. So yeah, this was today's problem statement. I hope you guys liked it. Make sure to like, share and subscribe to the channel. Thank you so much, and we are looking forward to see you in our next video.